In the bottom of this cart, there are bays of capacitors that get charged up. From the wall current charges up these capacitors. Then what happens is that goes through some electronics, and then it goes to two electrodes. And then when Dewey will push the button, we have a high voltage across this, and then a current will pass through this with enough energy to break every carbon-carbon bond in the system. And then when that breaks, it's going to reconstruct as graphene. So right now we have carbon black in there, which is an amorphous carbon, and you're going to see a bright flash when that takes place, because most of the energy is going into not heat, but this black body radiation, which is breaking every carbon-carbon bond in there, reconstructing, and then the excess is coming out as a bright flash of light. On the count of three, we're going to cause this to flash. 1, 2, 3.
The point is, you heat it up, and then when you cool it down, you make graphene. So that's why I've come up with the ideas of doing something similar to laser-induced graphene, but with others different carbon source, and use different source of energies, which is electricity.
Previously, we had taken a copper foil and we could grow graphene on that from many different carbon sources, one of them, for example, being cookies, Girl Scout cookies, or from dead roaches. But the problem with that is we could only make about a picogram of graphene, a very, very small amount of graphene that might be suitable for electronics. Here we can do it in bulk. This is a process that we call flash graphene, because we can take essentially any carbon material and turn it into graphene. Domestic US coal. The coal industry is just hurting so bad. So can we take coal, continue to mine it in large quantities, but use that coal for a much higher value product, so that we can put that coal into concrete, we can put that coal into building materials, we can put that coal into paints, into films, into asphalt, and now use that and keep that industry going, just taking a very inexpensive material that's like $100 a ton, and convert that to a higher value material, and then we only need a little bit of it to put it into all these different applications. It's just enormous what we're going to be able to do with this.